Okay, so I have written out the problem, copied it that you posted. This is a binomial probability problem because the two choices are you can roll a 2 or you don't roll a 2. So we do have two choices, so it is a binomial probability. So there is a formula that you can use. And these letters in the formula, well, n is the number of times the die is tossed, and here you can see it's tossed 50 times, so 50 is equal to n. N is the number of times a 2 is rolled, so these are on individual rolls, which we'll deal with in a minute. The probability of getting a 2 on an individual roll, well, a die has 6 faces and only one of them is a 2, so it's going to be 1 out of 6. And Q is the probability of not getting a 2. So that's going to be the complement of P. So I just do 1 minus P. And then you can use this formula. So if I was going to solve this directly, fewer than 7 2s means at most 6. Fewer than 7 means at most 6. And you have to be able to see that. Fewer than 7. So it can't be 7. So at most 6. So directly, the answer would be, well, the probability that you get no 2s on a roll. And so x would be 0, and you plug all these numbers into this formula. Or the probability that you get exactly 1 2 on a roll. Or the probability that you get exactly 2 2s on a roll. And you keep going until you get up to P of 6. So you'd have to put these x values into this formula 7 times and add them up, and that would give you your answer. Now on a TI-84 plus, it's a lot more simpler than that. This formula here, P of x, can be represented by the binom PDF command. And all you have to do is supply it with the n, your probability P, which is this one here, and your x. So I could do binom PDF 7 times for each of these because the x value would change. The n and p would be the same. But there's also this command. If you want the probability of getting at most capital A 2s, then that's a cumulative probability, so it's binom CDF, and we put in NP and A. And that's the one you want to use here. Okay, so fewer than 7 2s is at most 6 2s. And so your A here, your capital A, is going to be 6. And so I need the command, what is the probability that I'm going to roll at most 6 2s? So n is going to be 50. My probability for success, my probability of getting a 2 on an individual roll is 1/6. And I want to calculate what the probability of this is if it happens at most 6 times. So that's what I want to put into my calculator. Now, when I do that, I'm going to get this. I'm going to go ahead and write the answer out first. Now, you've been told to round to the nearest thousandth. All right, so that is to 3 decimal places. Like, how can you tell how many zeros are in the number 1,000? 3 zeros. So you round to 3 decimal places. So if I'm going to do that, then we have 1, 2, 3. So that's where I cut it off. But this 5, if your number here is a 5, 6, 7, 8, or 9, it's going to round this one up 1. So to 3 decimal places, my answer is going to be 0.251 or 0.251. So that's the answer. The only thing I'll show you is how to get that command. So I'm going to have to make this disappear while I do my calculations. So that's going to be, to get to the binomial CDF command, I'm going to do second and then vars, and then scroll down to binom CDF. There it is. Make sure you select binom CDF. And I have to tell it n, which is 50, comma, then my probability for success, which is 1/6, and I just type in 1 divided by 6. Don't type in a decimal because 1/6 is exact. You don't want to round any decimals, and if it has an infinite expansion, your calculator won't show that in a decimal. It'll only take it to 9 places. And then my capital A, which was 6, and then close the parenthesis. Okay, and so you can see that that's where I got that number from, and then when I round that to 3 places, I get 0.251. So that ends the video, and thank you for letting me help you.